So this is the first time I've done this, but I'm going to do a video review of Chapter 7. What I recommend you do is that you do each problem on your own and then stop and listen to the video explanation that I'm about to get. If I want to graph this exponential function, first of all I want to recognize that it is a decay function because our base is equal to 1/4, and anytime that base is between 0 and 1, it means that we are going to have a decay function. And so when I try to figure out how to graph this, the first thing I want to recognize is that in an exponential function, I have a horizontal asymptote, and it's always equal to k. So our horizontal asymptote is y equals -1. And so the first thing I want to do is I want to go and put that asymptote on the graph. Exponential functions always have a domain that's all real numbers, and it always has a range that's restricted by whatever the asymptote is. And so in this case, our range is going to go from -1 to infinity because it hasn't been reflected at all. Now, as I'm looking for numbers to find the shape of this exponential function, the first thing I want to do is I want to figure out what value of x is going to make that exponent equal to 0. And so if I plug in -3 for x, what I end up with is 3 times 1/4 to the 0 power minus 1. Well, anything to the 0 power is 1. So this is really just 3 minus 1, which is 2. And next thing I might look for to get another good shape to this graph. So right now I have -3 and 2. Let's go ahead and figure out where the exponent is equal to 1, because that's always a good thing to get. And so let's try -2. And when I do that, I get 3 times 1/4. This time that's going to give me an output of 1. And then we have -1. So this ends up being 3/4 minus 1, which is -1/4. And that gives us the basic shape of this exponential function. Make sure you don't touch my asymptote, and you put arrows on the end to show that it's continuing on forever in both directions. Next problem is an exponential decay problem because it says that we have a population that's decreasing at a rate of 3% annually. So if it's decreasing at a rate of 3%, then that means if it's at 100%, we need to do 1 minus 3%. And that means that our base is actually 97%. So every year, this city has 97% of its population from the year before. So we're going to have 0.97 be our base, and that's raised to the t. Now we know that the population was 120,000 to start with. That's always our initial value. So 120,000 times 0.97. And you can put t or x, but it's representing time. So there's part A. That's the function that represents that situation. And now part B, what will the population be in 10 years? Well, that's just going to be 120,000 times 0.97 raised to the 10th power. And so in 10 years, the population is going to be 88,491. It was 490.89523, but I don't think anybody wants to be that 8/10 or 9/10 of a person, so you'd round it to the nearest whole number. Now, because I'm writing with my finger right now, I'm not going to put this answer into a sentence, but you should. Anytime you answer a word problem, you should answer in words so that I know you know what the answer means. So in 10 years, this city will have a population of 88,491 people. All right, here a bacteria population started with 5,000 bacteria. So when there was 0 time had passed, you had 5,000 bacteria. After 8 hours, there were 28,000 bacteria. And we're looking at y equals a times b to the x. Well, we know in this case that a is equal to 5,000 because that's our initial value. So we already know that y equals 5,000 times b to the x. So now I'm going to use the other ordered pair to figure out what the function is. So we have 28,000 equals 5,000 times b to the 8th. So I'm going to divide by 5,000 on both sides. And I get 5.6 equals b to the 8th. And so I need to do the 8th root of both sides. And I get that b is equal to 1.24. So our exponential function is y equals 5,000 times 1.24 to the x. Please never make the mistake of multiplying a times b and raising that to the x. It is just this. So how many bacteria can be expected in the sample after 32 hours? All you're doing is plugging in 32 for x, so you get 5,000 times 1.24 to the 32nd. Which is, wow, big, 4,880,496. 4,880,496 bacteria. And again, you would write that in a sentence. Okay, graphing logarithmic functions. In this case, we're going to have a vertical asymptote, and that vertical asymptote is going to be the h value. So we're going to have an asymptote at x equals 2. So the first thing I'm going to do is I'm going to go put that on my graph. So logarithmic functions, the range is always unrestricted on these. So the range is going to be all real numbers. But the domain is always going to be restricted by whatever the vertical asymptote is. So in this case, the domain is going to go from 2 to infinity. So to find a couple of ordered pairs that would be good on this, you want to think about the log base b of 1, and because that's always 0, and log base b of b. Sorry, having a hard time writing with my finger, because that's always 1. So when I think about values of x that are first of all going to make that argument equal to 1, I'm going to plug in 3. Because we have 1/6 in that case times the log of 1/3 to the 0 to the 1. So that's going to be an output of 0. Now when I find a value of x that's going to give me, equal to the base, that's yucky, we're going to have 2 1/3. And when I plug in 2 1/3, I get log of 1/3 to the 1/3, and I have 1/6 times that. Well, that's basically 1/6 times 1, which is just 1/6. So we have 2 1/3, 1/6, so somewhere near there, and we have 3, 0. So we basically have this logarithmic function that's hugging the asymptote, and it's going to be very shallow because of the 1/3 base, and it's also multiplied by 1/6. So it's a very flat logarithm. The other thing you could do is figure out what the reciprocal of the base is, which is 3. And if I plug in 5, that means we have log of 1/3 of 3, and that's going to be -1 times 1/6, which will be -1/6. Evaluate log base 2 of 64. This is basically saying figure out what that equals. So log base 2 of 64 equals x. That means 2 to the x equals 64. Find a common base. 2 to the x equals 2 to the 6, therefore x must equal 6. Natural log of x plus 3 raised to the 5th equals 5. I'm just going to change this immediately into exponential form. My base is e, my exponent is 5, and I get that's equal to x plus 3 to the 5th. So if I take the 5th root of both sides, I basically get E equals x plus 3. Now E is a weird number, and so when I go to, in my calculator, to second divide, so it pulls up E, and I want to subtract 3 from E, I actually get that x is equal to negative 0.2817. A certain culture of bacteria will grow from 250 to 2,000 bacteria in 1.5 hours. Find the constant K for the growth formula. So we have y equals a times e to the kt. We have that the bacteria is growing from 250 to 2,000, so we need to find our constant. So it grew to 2,000. It started at 250. And we get E times K to the 1.5. So I'm going to divide by 250 on both sides. And I get 8 equals E to the 1.5K. So this is basically going to be the natural log of 8 equals 1.5K. And so we'll divide by 1.5 on both sides. And so we get the natural log of 8 divided by 1.5 is 1.3863. So our formula is y equals 250 times e to the 1.3863t. For a certain strain of bacteria, K, for a certain strain of bacteria, K is 0.728 when T is measured in days. So using that formula, how long will it take 10 bacteria to increase to 675 bacteria? So we're going to say 675 equals 10 times E to the K, which is 0.728 T. So we're going to divide by 10 on both sides. So we get 67.5 equals e to the 0.728t. Now you're going to change it into logarithmic form. So you're going to get the natural log of 67.5 equals 0.728t. So the natural log of 67.5 divided by 0.728, we get that T is equal to 5.7859, and that's days. So again, you would give me that answer as a complete sentence. Last problem. How much money would you need to invest in an account that compounds continuously at a rate of 4.5% for 10 years if you want to have $15,000 at the end of the 10-year period? So this is our PERT formula. And we want to have $15,000 at the end. We're not sure how much we want to invest, but we know that our rate is 4.5%, and we know that we're investing for 10 years. So when I get P by itself, I'm going to divide both sides by E to the 0.45. And so when we divide 15,000 by E to the 0.45, we get that we would need to invest $9,564.42, round to the hundredths place because that makes sense. Now look at the same exact information, but now we're going to look at it compounding monthly at a rate of 4.5%. So this time you're going to use the A equals P times 1 plus R over N raised to the NT. And if it's compounding monthly, that means that N equals 12, T is still 10, and R is still 0.045. So we want $10,000 at the end of that, and we have that it's going to be 1 plus 0.045 over 12 raised to the 12 times 10. And I'm going to let you guys go ahead and finish solving that on your calculator, and I'll trust that you'll get that right.